the two communities had a certain suspicion of each other because they've got different assumptions as well as objectives. And we were expecting very considerable difference in the results. But the reality is that you have a cloud of results where there is complete overlap. And so it was not possible in any particular aspects of the output from the models in the Water MIP runs to say that must be this type of model because it sits in this result area, and that must be that sort of model because it sits in that result area. Actually, they completely overlap.
That must be quite a relief to people, would you say?
I don't know if it's a relief. It's encouraging. It's definitely encouraging. Because the hydrological models are making assumptions that the land surface models don't make, you could say that for the land surface models, it's surprised that the hydrological models are doing such a good job. They're not designed to be of general use across the globe. And it would be the land surface modeller's view that you need to solve the energy balance in order to get a realistic answer. But effectively, the hydrological models have demonstrated you don't have to have all that complexity. But there are aspects of the way in which the land surface models behave that, as a result of the Water MIP study, could be improved upon by using the sorts of insights that we get from comparing with the hydrological models. So both sides are learning. The land surface models are realizing that they don't have the answer to everything, even though they think that their procedures are entirely physically based, and they haven't calibrated to particular areas. The hydrological modelers are learning because they're realizing there are some places where they do a good job and other places where they're not doing such a good job. And it turns out that there are certain regions of the planet where all the models are doing a really bad job compared to observations. This is particularly true for the high latitudes. There's a lot of technical reasons why the high latitudes are not done well, but I'll give you one example. The hydrological models take the rainfall information that we've provided and the snowfall information that we've provided, and they add up the equivalent amount of water in both components, and then they use the surface temperature that we provided to work out if it's rain or snow. And then they run their model, and they get results that look actually fairly good compared to the observations, but not perfect. The land surface models actually take the information that it's rain or snow at a particular time step, but they tend to lose water that should be retained in the soil because they're not set up, if it's frozen soil, to retain any liquid water. It just runs off in the model. And they tend to evaporate too much snow, and that's something that the hydrological modelers are not doing. So the hydrological modelers are getting slightly closer to the right result for the wrong reason. So the land surface modelers need to do a better job with the way they represent what happens with water, in particular in frozen soils, to get something that's more realistic. And they need to do something with the way the sublimation, which is the evaporation of the snow, is happening, so they can get closer to the reality. The hydrological modelers could do a better job if they actually use the information on is it rainfall or snowfall, because previous data sets haven't given that information. They're given for each time step the total amount of rain plus snow, whereas we've actually provided that because that comes from the era 40 data set, and it doesn't, the reanalysis data, and that doesn't come from NCAR inset. So there's no right answer, there's no one model that's perfect. These data that they use for forcing are not perfect. We can improve on them. But the point is that the collaboration and the comparison of results between models, between classes of models, and the comparison with observations is helping everybody move the models on, and we hope, we can't prove it, but we hope we will get closer and closer to having models that are as good as they can be. So it's obviously it's an ongoing process. But Watch in particular has provided an environment where the two modelling communities can learn from each other and are able to say, oh, well, we thought our models were doing fine, but actually we now realise they're not doing as well as we thought.
How close are they to speaking the same language? Because you referred to that before.
I would say that they are speaking the same language now.